Welcome to the notes for the Infinite Geometric Series. Before we start the notes, I want you to think about Pioneer Park. You want to go to Pioneer Park. This, obviously, is a great representation of Pioneer Park. This is you. You want to walk to Pioneer Park, so you need to go from where you are all the way over to Pioneer Park. Now, in order to get to Pioneer Park, first you have to walk halfway there. Then, in order to get to Pioneer Park, you need to walk half of that distance before you can get there. Now, you're here. Before you can get over here to Pioneer Park, you want to be by this tree. You have to walk half the distance. So there you are. You need to walk half the distance again before you can get there. And you keep having to walk half the distance to where you want to be. And theoretically, it seems like you're never going to get there. But seriously, right now, if you walk outside of your house or school or wherever you're watching this video, and you start walking to Pioneer Park, you're going to get there, even though you have to keep going half the distance first. That's an infinite geometric series. In an infinite geometric series, we can actually take an infinite amount of terms, add them together, and get a sum. And I'm going to show you why in this video. So let's consider this geometric series. This is very similar to the problem that I just talked about. In order to get somewhere, you need to walk halfway there. Then you'd walk half of that distance, which is a quarter, another half of that distance, which is 1/8, and so on. So let's just graph this and see what happens. So when I do my infinite geometric series, I want to think about the sums. My first sum, the big S represents a sum. My first sum is 1/2. So if I graph this 1/2, I am going to be right here. Then my second sum is 1/2 plus 1/4, which gives me 3/4. So at 2, I'm at 3/4, which is 0.75. My third sum, S sub 3, I want to add my first 3 terms, which will give me 7/8. So at 3, I am about here. My fourth sum, I add the first 4 terms, which gives me 15/16. So at 4, I am about here. Do you see what's happening? I'm getting closer and closer and closer to this. Closer and closer and closer to 1. So what I want to do is think about the formula. Think about the formula for our series, for our geometric series. And the formula is this. It's S sub n is equal to 1 minus r to the nth over 1 minus r times a sub 1. And if I substitute in the values that I have in this problem, I would have 1/2 is my a sub 1 times 1 minus 1/2 raised to the nth over 1 minus 1/2. Now this would give me 1/2 times 1 minus 1/2 raised to the nth over 1/2, which would simplify to 1 minus 1/2 raised to the nth. Now, if you remember, this is a geometric series. That means I'm taking the sequence and I'm adding all of the terms together. N, however, is finite, not like what we were just doing with infinite, but n is finite. But now if you think about this formula, you have 1 minus 1/2 to the n. As n is getting really, really, really huge, this term is getting really, really, really small. It's getting closer and closer and closer to 0. So as n gets huge, what I'm doing is I'm taking 1 minus something so close to 0. And that is why I'm getting closer and closer and closer to this line 1. Never actually going to touch it, but the sum is going to be 1 as I get closer and closer and closer. Now, the formula for an infinite geometric series is actually really simple. The sum of an infinite geometric series with the first term a sub 1 and a common ratio of r is given by s is equal to a sub 1 over 1 minus r, when the absolute value of r is less than 1. Now, that's important, that the absolute value of r is less than 1. It does not work if the ratio is bigger than 1, because what happens if the ratio is bigger than 1, our numbers are getting bigger and bigger and bigger and bigger, and they're never converging to a certain sum. So if the absolute value of r is greater than 1, then the series would keep getting larger. And we say that that diverges. The series isn't going to a certain sum. If we're using this formula and the absolute value of r is less than 1, then we say that the series converges.